Hello guys, welcome back to my YouTube channel. Myself Parimala, currently proceeding fourth sem in Sri Venkateswara College of Engineering. And today's subject is discrete mathematical structures and the topic the use of quantifiers and its definitions and proofs of theorems. So here is the introduction to quantifiers, where the quantifiers are the symbols used in the mathematical logic to express the quantity of the statement. And the two primary quantifiers are universal and existential. Understanding quantifiers is essential for formal mathematical reasoning and proofs. So here we can look some few quantifiers, that is a little, few, a lot of, many, much, any, lots of, some. So little cannot be countable, but it's uncountable. The few is which is uncountable, and a lot of, and it is both countable and uncountable. And the many, it is only the countable but cannot be uncountable. Much, it cannot be countable but it's uncountable. And here are a few examples where it is countable noun or uncountable noun. Universal quantifiers, it denoted by which is of subset assets that the property holds for all the elements in the given set. The subset of x, p of x means p of x is true for every element x. Universal quantifiers are often used in definitions and theorems to establish the general truths. Here is the example where let p of x must be taken as discrete mathematics course, and p of x can be taken as x is a student, c is student. Universe of discourse for both p of x and q of x is UNL students. And next quantifier is existential quantifier. It is denoted by the which is E, and it indicates that there exists at least one element in the set of for which property holds. For existence, the subset of x, p of x asserts that there is at least one x such that p of x is true. This quantifier is crucial in proofs involving the existence of solutions or counterexamples. It is denoted by turned E, which is ulta E. Combining quantifiers. The quantifiers can be combined to express more complex statements about sets. For example, this set is means that every x there exists a y such that px, y holds. Properly understanding the order of quantifiers is essential, as it can significantly change the meaning of a statement. Quantifiers in definitions. The definitions often utilize the quantifiers to establish precise meaning for the mathematical concepts. For example, it is defined as a subset of x, the reverse of y, if for every x there is unique y. These precise definitions help create a solid foundation for further theorems and proofs. In this also we can say many quantifiers like little, few, lot of, many, much, any, lots of, some. These quantifiers they are used in many ways. Quantifiers in theorems. Theorems frequently involve the quantifiers to assert general properties of mathematical objects. And theorem might state the subset of x, p of x gives q of x, meaning if p holds for x, then q also holds. Use of quantifiers in theorems allows mathematicians to convey broad concepts subsequently. In theorems, it is involved in quantifiers like general properties of mathematical objects, wherein we can solve the quantifiers using the theorems. Proofs and quantifiers. Proofs often depend on the correct interpretation and manipulation of quantifiers. Common strategy includes directly proving universal statements or providing a counterexample for existential claims. So here is understanding how to construct the proofs involving quantifiers is critical for mathematical rigor. So proofs and quantifiers are almost used for correcting the interpretation and manipulation of the quantifiers. These are used very often in the mathematical structures wherein it involves the quantifiers is critical for mathematical rigor. Proof techniques for universal statements. To prove the statement of the form which is of reverse x of p of x, one must show that p of x is true for an arbitrary x. Techniques such as direct proof and proof by contradiction can be employed. These methods help establish the truth of universal statements systematically. So proofs and techniques for universal statements, they can be used in everywhere wherein establish the truth of universal statements. For existential statements, proving an existential statement which is reverse of Ex P of x requires demonstrating at least one specific example of x for which P of x is true. Constructive proofs provide a concrete example, whereas non-constructive proofs may rely on reasoning on direct arguments. Both methods are valid, but the choice depends on the context and goals of proof. Both the methods are valid, but the choice depends on the context and goals of the proof. So here is a conclusion where quantifiers play a vital role in the definitions, theorems, and proofs in mathematics. A solid understanding of both universal and existential quantifiers is necessary for rigorous mathematical reasoning. By mastering quantifiers, one can enhance their ability to formulate and prove mathematical statements. So these two quantifiers, the Venn diagrams useful in quantified statements. Definition of, if we consider the definition of the trapezoid, a quadrilateral with a pair of parallel sides, and could a parallelogram be quantified or trapezoid? These two are the important types of the quantifiers. Here I end with the topic. Thank you.